Our next story. What if life on Earth began when interstellar objects crashed here? Something I've talked about on the podcast a couple of times. Is about the OSIRIS-REx mission, which I do have an update on, which I mentioned in the beginning of the show. But let's talk about exactly what we have going on with this particular one. Let me turn the boom. So back a couple of years ago, there was this thing called Oumuamua. And that's what we're going to have to start off talking about, this basically asteroid that came from outside of the solar system that many believe was a artifact or a signal sent to us by a civilization in a different galaxy as a message to us. What that message was, whether it's a drone to spy on us, whether it's a message that they would expect us to open and read and get some kind of wisdom, or if it was some other thing. That's what some people believe that this object called Oumuamua was. Now, what is this thing? Because in order to understand what the seeding of our planet is, we do have to talk about Oumuamua, which I don't think I've done on this show. This is from NASA. Oumuamua is the first confirmed object from another star to visit our solar system. This interstellar interloper appears to be a rocky, cigar-shaped object with a somewhat reddish hue. The object was named Oumuamua by its discoverers. It means a message from afar arriving first in Hawaii. Oumuamua is up to 1/4 mile wide, long and highly elongated, perhaps 10 times as long as it is wide. That aspect ratio is greater than that of any asteroid or comet observed in our solar system to date. While its elongated shape is quite surprising, and unlike objects seen in our solar system, it may provide new clues into how other solar systems are formed. And then in the video here, you can see it. This is it. And then how far away is it? Go. Oh, where is it in relation to us right now? So it's pretty far away. All right, I guess I won't be able to see exactly where it is. The observations suggest this unusual object had been wandering through the Milky Way, unattached to any star system for hundreds of millions of years before its chance encounter with our star system. Immediately after its discovery, telescopes around the world were called into action to measure the object's orbit, brightness, and color. Urgency for viewing from ground-based telescopes was vital to get the best data. Combining the images from the FORS measurement on the ESO telescope using 4 different filters with those of other large telescopes, a team of astronomers led by Corinne Meach of the Institute for Astronomy in Hawaii found that Oumuamua varies in brightness by a factor of 10 as it spins on its axis every 7.3 hours. No known asteroid or comet from our solar system varies so widely in brightness with such a large ratio between length and width. The most elongated objects we have seen to date are no more than 3 times longer than they are wide. This is 10. Interesting. Then here's a picture of it. Could not really see it very well. The interstellar object Oumuamua is at the center of this image, circled in blue, surrounded by the trails of faint stars that are smeared as the telescopes tracked the moving comet. So that's from the telescope. This unusually big variation in brightness means that the object is highly elongated, about 10 times as long as it is wide, with a complex convoluted shape. We also found that it had a reddish color, similar to objects in the outer solar system, and confirmed that it is completely inert without the faintest hint of dust around it. These properties suggest that Oumuamua is dense, composed of rocky and possibly metals, has no water or ice, and that its surface was reddened due to the effects of irradiation from cosmic rays over hundreds of millions of years. A few large ground-based telescopes continue to track the fading object as it receded from our planet. Two of NASA's space telescopes, Hubble and Spitzer, tracked the object traveling around 85,700 miles per hour, or 38.3 kilometers per second relative to the sun. Okay. Astronomers estimate that an interstellar object similar to Oumuamua passes through the inner solar system about once per year, but they are faint and hard to spot and have been missed until now. It is only recently that survey telescopes such as Pan-STARRS 1 are powerful enough to have a chance to discover them. So that is Oumuamua. Okay. One thing that we could all agree on was that the detection of this object indicated that ISOs regularly enter our solar system. What's more, subsequent research has revealed that on occasion, some of these objects come to Earth as meteorites and impact the surface. So there could have been at one point, like we just had said, Oumuamua, those kind of objects where they're coming possibly from outside of our own solar system. Possibly we get one of those a year, but we just don't know about it because we're not detecting these. I mean, this thing is pretty large, but there are many other ones that potentially are, I don't know, say 100 feet across that are very, very small, that are so millions of miles away from us and never come too close to us. Seeing that kind of stuff is very hard to see, obviously. So maybe we have hundreds of these every year. We just aren't able to track them. But how many over the course of time have come into and impacted Earth? Dozens, hundreds, thousands, millions? Because if that's the case and they seeded the Earth, they brought with them different metals, different compounds, they had water on them, they have oxygen, they have different whatever that they have on these different atomic molecules on them that they bring to our planet that become a part of our atmosphere, that become a part of the very soil, the water, everything here on this planet, and could potentially start the journey towards life. In a recent paper, a team of researchers considered the implication of ISOs being responsible for panspermia, the theory that the seeds of life exist throughout the universe and are distributed by asteroids, comets, and other celestial objects. According to their results, ISOs can potentially seed hundreds of thousands or possibly billions of Earth-like planets throughout the galaxy. The team was led by David Coe, a senior student at Thomas Jefferson High School for Science and Technology. He was joined by Peter Plavchan, an associate professor of physics and astronomy at George Mason University, and the director of the Mason Observatories, and Michael Summers, a professor of astrophysics and planetary science at GMU. Their paper, The Implications of Oumuamua on Panspermia, recently appeared online and is being reviewed for publication by the American Astronomical Society. To briefly summarize, panspermia is the theory that life was introduced to Earth by objects from interstellar medium. Let's keep going. Here we go. 2 years later, after Oumuamua, a second ISO was detected entering the solar system, except there was no mystery about its nature this time. As it neared our sun, it was called 2I Borisov, formed a tail indicating that it was a comet. Subsequent research has shown that some of these objects become meteorites that impact on Earth's surface, and a few have even been identified. This includes CNEOS 2014-0108, a meteor that crashed into the Pacific Ocean in 2014 and was the subject of the study by the Galileo Project. As Cow explained, the detection of these interstellar visitors also has implication for panspermia and the ongoing debate about the origins of life on Earth. And also, I think interesting questions about the origins, or the possibility, I should say, not origins, but the possibility that we're being sent messages. I don't know. I don't know. I don't know. Maybe there's another civilization out here that says, let me bing shoot this meteorite to land into what they call the Pacific Ocean that gets discovered, and hopefully they are able to get our message. Or maybe this was something that millions and millions of years ago, there was a civilization on the brink of collapse at the end of their society. And they thought, you know what? I don't know how much longer we'll be here, but let's at least send out this message. Let's at least try and help another civilization out. Unfortunately, ours is coming to the end. Our experiment on this planet didn't work, and we're gonna tragically die. But let's do one last hoorah and send out this message to this planet that we can see has life on it. That's millions and millions of light years away. Let's send this thing out and hopefully it lands there. That's a possibility. That's 100% a possibility. To say that's not is silly. If we were on the edge of crashing down, of disease and political strife, and you have nuclear bombs going off, and you have the world basically coming to an end, have a giant meteor that's going to take out the entire planet coming into contact with us, why wouldn't we? And guess what? There's only one Earth, and there's humans here on Earth. Now, who's to say that there is not another planet out there where they didn't evolve the way that we evolved? Maybe here on Earth we wouldn't send anything out because we're too focused on trying to save ourselves. But maybe there's a planet out there where they said our demise is coming. Let's send out a message of wisdom to these other places around the universe. That's a possibility. It's not science fiction, it's a possibility. Now, is that what's happening here? I do not know. I do not know. Back to the article. Oumuamua serves as a novel data point for panspermia models, as we can use its physical properties, particularly its mass, size, and implied ISM number density, to model the number, density, and mass density of objects in the interstellar medium. These models allow us to estimate the flux density and mass flux of objects in the interstellar medium, and with these models, we can approximate the number of objects that impacted Earth over 0.8 billion years. Knowing the total number of collision events on Earth over that 0.8 billion year period is vital for panspermia, as a greater number of collision events with interstellar objects made over that period imply a higher probability for panspermia. In short, the physical properties of the interstellar Oumuamua allow for the creation of mathematical models that determine the plausibility of panspermia. In addition to the mathematical models that consider the physics behind panspermia, Cow and his colleagues applied a biological model that describes the minimum object size needed to shield extremophiles from astrophysical events. Things like supernova, gamma ray bursts, large asteroid impacts, passing by stars. As addressed in a previous article, recent research has shown that cosmic rays erode all but the largest ISOs before they reach another system. So that's an interesting thing about Oumuamua. It wasn't completely eroded by the cosmic rays from our own sun. Maybe there was way out when it was first coming in, it had sort of a protective layer on the outside, and the sun kind of broke that down. But it was able to get fairly close to Earth without being completely destroyed. Based on their combined physical and biological models, the team derived estimates for the number of ejecta that struck Earth before life emerged. According to the oldest fossilized evidence found in Western Australia from rocks dating to the Archean eon, different from epochs. I don't know all this stuff. The earliest life forms emerged 3.5 billion years ago. Said Cow, we conclude that the maximum probability that panspermia sparked life on Earth is on the order of magnitude of 10 to 5 or 0.001%. Although this probability appears low, under the most optimistic conditions, potentially 4 times 109 total habitable zone planets exist in our galaxy, which could indicate a total of 104 habitable worlds harboring life just in our galaxy alone. So possibly 104 planets in this galaxy have life on them, and there are billions and billions of planets. So yeah, that makes sense. Yeah, if it's a very low percentage of planets actually make it, and we're one of those planets, yeah, that makes sense. Additionally, we restricted our analysis to the first zero point 0.8 billion years of Earth's history prior to the earliest fossilized evidence for life. But because life can be seeded at any point in a planet's lifetime, and planets have significantly longer habitable lifespans, up 5 to 10 billion years, we boosted our estimate for the total number of habitable worlds harboring life in our galaxy by one order of magnitude. From this, they obtained a final result of about 105 habitable planets that could harbor life in our galaxy. However, these estimates are based on the most optimistic projections regarding planetary habitability. So it could be 10. There might be 10, or there might just be one planet in the Milky Way galaxy called Earth where there's life on it. That's a possibility. And now apply that same philosophy to the other places. There could be a lot of different worlds out there. We're just stretched out far too wide, far too wide. In other words, it assumes that all Earth-sized rocky planets orbiting within habitable zones are capable of supporting life, meaning they have thick atmospheres, magnetic fields, liquid water on their surfaces, and all life-bearing ejecta that survive entering our atmosphere are capable of depositing microbes on the surface. There's a little video right here of Oumuamua. You see Joe Rogan here talking about what exactly that object is. Very cool. As Cal summarized, the results do not prove panspermia or settle the debate on the origins of life here on Earth. Nevertheless, they provide valuable insight and constraints on the possibility that life came here via objects like Oumuamua. Very, very cool. Then here is another article. I'll post this in the description to the video. This is kind of going more deep into yeah, this is originally from the day that they discovered this device. You see this stuff right here. There it comes in right there from the top. Gets shot back out. This was basically one of the first articles on the topic when they discovered it. And then this is kind of what they used to look at it. the Pan stars, a single research project at the Institute for Astronomy, 1.8-meter diameter telescope in Maui. Almost 1.4 billion pixels. Dang! Crazy. And here is the paper in all of its glory. Now, this paper, I'm not going to go through it, but I will include it in the description, and I do recommend that you go look into it because I think this is pretty cool.